What is JavaScript? JavaScript is a versatile programming language that is primarily used to add interactivity and dynamic behavior to web pages. It allows developers to create rich user interfaces and complex web applications. As part of the web development trio, alongside HTML and CSS, JavaScript is executed on the client's browser, providing immediate interaction without the need for server-side processing. The code provided is a simple JavaScript statement that demonstrates the language's ability to display a message to the user. When executed within a web browser, it will invoke a pop-up alert box displaying the text "Hello World." This is often one of the first pieces of code written by people learning JavaScript, as it's a straightforward way to see immediate results from a script. Brief history of JavaScript. JavaScript, initially named Mocha, was created in just 10 days by Brendan Eich in 1995 while working for Netscape Communications Corporation. It was intended to be a scripting language that complemented Java by allowing for dynamic content in web pages. Renamed as JavaScript, it quickly became an indispensable part of web development. In 1997, JavaScript was standardized as ECMAScript to ensure consistent behavior across different web browsers. Over the years, it has evolved significantly with ECMAScript versions, bringing new features and improvements. The code shown is a basic JavaScript command that outputs the string "Hello World" to the console. It is often one of the first examples used to demonstrate how to run JavaScript in a web browser's developer tools console or in a Node.js environment. The command console.log is a function that prints out its arguments to the debugging console. Despite its simplicity, it serves as a testament to how JavaScript can manipulate and interact with a web environment. JavaScript versus ECMAScript. JavaScript is a high-level programming language that is commonly used for creating interactive effects within web browsers. ECMAScript, on the other hand, is a specification that standardizes scripting languages like JavaScript. JavaScript conforms to the ECMAScript specifications, but it also includes additional features beyond the ECMAScript standard. This line of JavaScript code prints out the string "Hello ECMAScript" to the console. While this example adheres to the ECMAScript specification, JavaScript as a language allows for additional APIs like the Document Object Model (DOM) and the Browser Object Model (BOM), which are not part of ECMAScript. Setting up a development environment. Before you start writing JavaScript code, you'll need an environment where you can write and execute your code. The simplest setup for a beginner is using a local development environment, which consists of an editor and a browser. The code provided is a basic JavaScript command that can be run in a browser's developer console or any JavaScript-capable environment. This command logs the string "Hello World" to the console. It's a common tradition to use this phrase as the first piece of code when learning a new programming language. Including JavaScript in an HTML file. Incorporating JavaScript into an HTML file enables dynamic functionality on web pages. This can be done in two primary ways: inline within a script tag or by linking to an external JavaScript file. Here's how you can include JavaScript directly within your HTML document. The code demonstrates an HTML file structure with a script tag in the head section. JavaScript code is placed inside the script tag, where console.log outputs a message to the browser's console. While the example shows the script in the head, it can also be placed in the body, often before the closing body tag, to allow for the HTML elements to load before the JavaScript executes. JavaScript console. The JavaScript console is a development tool built into modern web browsers. It allows developers to log information, interact with a web page's JavaScript code, and monitor errors in real time. It can be used for testing, debugging, and executing JavaScript code within the context of the browser. This line of code uses the console.log method to print the string "Hello World" to the browser's console. It is often used to verify that code is running, or to display the contents of a variable for troubleshooting purposes. Syntax and structure. JavaScript syntax is the set of rules that defines a correctly structured JavaScript program. Understanding the syntax is crucial to write error-free and well-structured code. Let's look at a basic JavaScript structure, including variables, if statements, and functions. The code declares a variable greeting using the var keyword followed by an assignment of a string value. Then, a function named sayGreeting is defined, containing an if statement that checks if greeting has a truthy value. If it does, the alert function displays the value of greeting. Lastly, sayGreeting is called to execute the function. Variables var let const. In JavaScript, variables are containers for storing data values. The var, let, and const keywords are used to declare variables, each with its scope and mutability. The var keyword declares a variable with function scope, or global if declared outside any function. Let introduces a variable with block scope, which is generally preferred for its better predictability. Const is also block scoped, but creates a constant reference to a value, meaning the variable can't be reassigned to a new value. Although mutable objects like arrays and objects can still be modified. Data types number string, Boolean object array null undefined. JavaScript provides various data types to hold different types of values. There are 7 fundamental data types in JavaScript: number, string, Boolean, object, array, null, and undefined. Each data type serves a specific purpose and uses. The code snippet declares variables with different JavaScript data types. Age is a number, typically used for arithmetic calculations. Name is a string, a sequence of characters. IsStudent is a Boolean representing true or false. Person is an object, which is a collection of key-value pairs. Grades is an array, a list-like structure that can hold multiple values. Empty var is set to null, explicitly indicating the absence of a value. Undeclared var is undefined, as it hasn't been assigned a value. Type coercion. Type coercion is the process by which JavaScript converts one data type to another automatically in the context of an expression. This occurs because JavaScript is a loosely typed language. The coercion can happen for various reasons, such as when performing operations between mixed data types, or when evaluating expressions in conditional statements. In the code, the string 5 and the number 3 are being concatenated using the plus operator. Because one of the operands, 5, is a string, JavaScript coerces the number 3 into a string and then concatenates both, resulting in the string 53. Type coercion is why we must be careful about the types of values we are manipulating in JavaScript to avoid unexpected results. Operators assignment, arithmetic comparison logical. Assignment operators are used to assign values to variables. The most common assignment operator is equals, which simply assigns the value on the right to the variable on the left. The code declares a variable x and assigns it the value 10. Then, it uses the plus equals assignment operator to add 5 to the current value of x, effectively updating x to 15. Conditional statements if-else switch. Conditional statements allow a program to execute different code blocks based on certain conditions. The if statement performs a block of code if a specified condition is true. Combined with else and else if, it can form a chain to check multiple conditions. The switch statement is used to perform different actions based on different conditions, often more efficient than multiple else if blocks when checking the same variable for many constant values. In the provided code, a variable fruit is defined with the value apple. An if statement checks if fruit is apple, which is true, so apple was selected is logged to the console. Had it been banana, the else if block would execute. Any other value would trigger the else block, logging the phrase. Some other fruit was selected. Below that, a switch statement accomplishes the same task using cases. Again, the case matching apple executes, so apple was selected is logged to the console. The break keyword prevents the subsequent cases from being executed even after a match is found. Prompt alert and confirm. Prompt alert and confirm are methods provided by the window object in browsers. They are used to interact with the user, to collect input, to inform them of something, or to get their confirmation on an action, respectively. The code shows 3 window methods in action. Firstly, prompt displays a dialog with a text input and returns the input value. Alert then uses the returned value to display a welcome message. Lastly, confirm is used to show a dialog with OK and cancel to confirm or cancel an action. The result of confirm, true for OK, false for cancel, is stored in delete confirmation. Loops for while, do while for in for of. The for loop provides a concise way of writing a loop that needs to be executed a specific number of times. The for loop has three parts: initialization, let I equals 0, condition, I 5, and increment I++. The loop starts with I equals 0 and runs until I is no longer less than 5, incrementing I by 1 after each iteration. The console.log I statement outputs the current value of I. Functions declaration expression arrow functions. Function declarations are one of the ways to define a function in JavaScript. They are hoisted, meaning they can be called before they are defined in the code. The code declares a function named greet that takes one argument, name. It outputs a greeting to the console. The function is then called with the argument Alice, resulting in hello Alice being printed to the console. Scope global versus local. In JavaScript, scope refers to the visibility of variables and functions in various parts of the code. Global scope means the variable or function is accessible from anywhere in the code. Local scope, often referred to as function scope or block scope for let and const, means the variable or function can only be accessed within the function or block it is defined. In the provided code, global var is declared outside any function, giving it global scope. Local var is declared within example function, giving it local scope to that function. Accessing global var is possible from both inside and outside example function. However, local var is only accessible within example function, and attempting to access it from outside results in a reference error. Hoisting. In JavaScript, hoisting is a behavior where variable and function declarations are moved to the top of their enclosing scope before code execution. This means variables and functions can be used before they are declared in the code. The var myvar equals 5 declaration is hoisted to the top, but its initialization with the value 5 is not. Therefore, a console.log var before the declaration outputs undefined. After the declaration, console.log myvar outputs 5. Similarly, the declaration of function myfunc is hoisted, allowing it to be called before the point of its definition in the source code. Thus, console.log myfunc can execute without error and logs called myfunc because the entire function definition is hoisted, unlike the variable, which only has its declaration hoisted, not initialization. Strict mode. Strict mode is a feature in JavaScript that enables a strict operating context, where some of the more lax and error-prone aspects of JavaScript are restricted. It is a literal expression that can be added to the beginning of a script or function to enable this mode. Enabling strict mode can catch common coding bloopers, prevent the use of global variables, and make it easier to write secure JavaScript. In the code provided, use strict is declared at the start of the script, indicating that the script should be executed in strict mode. This means that certain errors that would otherwise be ignored or would fail silently will now cause an error or throw exceptions. For example, when x is assigned the value of 3.14 without being declared with var, let, or const, it will throw a reference error in strict mode, which helps in catching and fixing undeclared variables. Function arguments and parameters. In JavaScript, functions can take inputs known as parameters. When you call a function, you provide values known as arguments, which correspond to these parameters. Parameters act as variable declarations within the function, and the passed arguments are the actual values the function will use during its execution. In the provided code, the function greet is defined with two parameters, name and age. When we call greet with the arguments Alice and 30, these values are passed to the function. Inside the function, name now holds the value Alice, and age holds the value 30. The function then logs a greeting to the console using these values. Default parameters. In JavaScript, functions can have default parameters. A default parameter is a parameter that assumes a default value if no value or undefined is passed into the function. This can make functions more flexible and prevent errors from missing arguments. In the code example, the greet function is defined with one parameter, name, that has a default value of guest. When the function is called without an argument, name is set to guest. When the function is called with an argument, that argument value overrides the default value. This allows the greet function to be called with or without specifying a name. REST parameters and spread operator. REST parameters allow us to represent an indefinite number of arguments as an array, providing a way to handle function parameters more flexibly. In this code, the sum function is defined with REST parameters, indicated by numbers. This means numbers is an array containing all the arguments passed to the function. Inside the function, the reduce method is used to sum all the elements of the numbers array. When calling sum1, 2, 3, 4, the function returns 10. Function hoisting. In JavaScript, function hoisting refers to the behavior where function declarations are moved to the top of their containing scope during compilation. This allows functions to be called before they are declared in the code flow. In the code above, the function hoisted function is called before its declaration. Due to function hoisting, JavaScript knows about the function before execution enters the block where it's defined. Thus, I am hoisted is successfully logged to the console. Closure. In JavaScript, a closure is a function that remembers the variables from the place where it is defined, regardless of where it is executed later. This happens when a function is nested inside another function and has access to the outer function's scope. The function createGreeting receives a string greeting and returns a new function. This new function takes one parameter, name, and returns a greeting message. Due to closure, the inner function retains access to the greeting variable even after createGreeting has finished execution. The variables sayHello and sayHi are each assigned a function generated by createGreeting, each with a different greeting. When they are called with names Alice and Bob, they remember the greetings hello and hi respectively, illustrating how closures work in JavaScript. IIFE, immediately invoked function expressions. An immediately invoked function expression, IIFE, is a JavaScript function that runs as soon as it is defined. It is a design pattern, which is also known as a self-executing anonymous function and contains two major parts. The first is the anonymous function with lexical scope enclosed within the grouping operator. This prevents accessing variables within the IIFE idiom, as well as polluting the global scope. The second part creates the immediately invoked function expression, through which the JavaScript engine will directly interpret the function. In the code, a function is defined within parentheses, which creates the function scope, and then immediately executed by the following. The variable message is not accessible from the outside scope, thus keeping it private. This pattern is beneficial because it offers a way to isolate variable declarations and minimizes global scope pollution. Callback functions. In JavaScript, a callback function is a function that is passed into another function as an argument. This technique allows a function to call another function. A callback function can run after another function has finished execution, which is particularly useful for asynchronous operations. In the given code, greeting is a function that takes a single argument name and then alerts a greeting message. Process user input is another function that takes a callback function as its parameter. It prompts the user to enter their name, stores the input in a variable name, and then calls the callback function, passing in the user's name as a parameter. Finally, process user input is called with greeting passed as the callback function, so when the user enters their name, they are greeted with an alert. Higher order functions. Higher order functions are functions that can take other functions as arguments or return them as results. This concept is a cornerstone in JavaScript, as it enables the creation of more abstract modes of operation and the manipulation of behaviors with functions. They are heavily used in functional programming to create more modular and reusable code. In this code snippet, repeat 3 times is a higher order function because it takes another function action as an argument. It calls this action function 3 times. The function greet is then defined, printing hello world to the console. Finally, repeat 3 times is invoked with greet as an argument, which results in hello world being printed 3 times. This demonstrates the use of higher order functions to abstract the notion of repeating an action without having to know the specifics of the action being repeated. Recursive functions. Recursive functions are functions that call themselves in order to divide a problem into smaller subproblems. A base case is used to stop the recursion. we'll write a recursive function to calculate the factorial of a number, which is a classic example of recursion. Our function factorial calculates the factorial of a number n. If n is 0 or 1, it returns 1, the base case that stops the recursion. If n is greater than 1, the function returns n multiplied by the factorial of n-1. This recursive call continues until it reaches the base case. Thus, factorial 5 returns 5 factorial 4, and so on, until factorial 1 returns 1, resolving the recursive calls. Objects, properties, methods, this keyword. In JavaScript, objects are collections of key-value pairs. The keys are often referred to as properties, which can hold values of any data type. Furthermore, properties that are functions are called methods. The this keyword within an object's method references the object itself. In the given code, person is an object with two properties, first name and last name. There is also a method named fullName. When fullName is called, this.firstName refers to the person object's firstName property, and this.lastName refers to last name. Therefore, person.fullName returns the full name of the person by concatenating first name and last name with a space between them. Object constructors and prototypes. In JavaScript, constructors are functions used to create objects. When you call a constructor function with the new keyword, JavaScript creates a new object that inherits from the constructor's prototype. The prototype is a property available on all functions, but when dealing with constructors, its main use is to share methods and properties between instances of a constructor function. In the provided code, we define a constructor function person that takes name and age as parameters and assigns them to the newly created object. We then add a method greet to person's prototype. This method will be accessible to all instances of person. Next, we create two instances of person by calling new person with different arguments. Finally, we call the greet method on each instantiated object, which returns a greeting message demonstrating that both person1 and person2 have access to the same greet method from the constructor's prototype. Object-oriented programming classes and inheritance. In JavaScript, classes are a template for creating objects. They encapsulate data with code to work on that data. Inheritance is a way to form new classes using classes that have already been defined. The new classes, known as derived classes, inherit attributes and behaviors from the base classes. The code defines a base class animal with a constructor to initialize the name and a method speak. The derived class dog extends animal, indicating it inherits from animal. Dog overrides the speak method to provide its own behavior. An instance of dog is created with the name Mitzi, and calling speak on this object invokes the overridden method, logging Mitzi barks to the console. Properties access dot notation versus bracket notation. In JavaScript, properties of objects can be accessed using dot notation or bracket notation. Dot notation is used when you know the name of the property you're trying to access, while bracket notation is useful in cases where the property name is dynamic or cannot be represented as a valid identifier. In the code example, person is an object with several properties. The dot notation, person.name, is used to directly access the name property. It's simple and straightforward. However, the favorite color property includes a space, making it an invalid identifier, so bracket notation must be used to access it. Person, favorite color. The bracket notation is also shown being used with the variable property name to dynamically access the age property. This showcases bracket notation's flexibility in handling property names that are not valid identifiers or are not known until runtime. Arrays methods iteration. Arrays in JavaScript provide several methods that allow you to iterate over the array elements. These methods perform actions like executing a function on each item in the array, or creating a new array based on the results of a function. These iteration methods are higher-order functions, meaning they take other functions as arguments. In the provided code snippet, we use the array.prototype.map method, which creates a new array by calling the provided function on every element in the array on which it is called. Here, each number in the numbers array is doubled, and the result is stored in the doubled array, which is then logged to the console. The output of this code would be 2, 4, 6, 8. each element of the original array has been multiplied by 2. Array manipulation, push, pop, shift, unshift, slice, splice, etc. The push method adds new items to the end of an array, and pop removes the last item from an array. Here's how to use them. The push method adds orange to the end of the fruits array. Then pop removes orange and stores it in last fruit. After these operations, fruits will have only apple, banana. Destructuring assignment. Object destructuring in JavaScript allows you to unpack values from objects into distinct variables. Consider an object representing a user with properties name and age. In the code above, the user object has 2 properties, name and age. Using object destructuring, these properties are unpacked into 2 separate variables, name and age, which now hold the values Alice and 25, respectively. This is a much more concise way to access object properties compared to the traditional dot notation, especially when multiple properties are needed. JSON parsing and stringification. JSON, JavaScript object notation, is a lightweight data interchange format that is easy for humans to read and write, and easy for machines to parse and generate. JSON parsing and stringification are fundamental operations that allow conversion between JSON text and a JavaScript object. In the provided code, we start with a JSON-formatted string, JSON string, that represents an object with properties for name, age, and city. We use JSON.parse to convert this string into an actual JavaScript object, AE. We then access the name property of the object and log it to the console. In the next part, we define a JavaScript object, JSON object, and use JSON.stringify to convert it into a JSON string, stringified, which we then log to the console. Parsing transforms a JSON string into an object, while stringification transforms an object into a JSON string. Map set, weak map, weak set. Map is a collection of keyed data items, just like an object. But the main difference is that map allows keys of any type. In the code snippet, a new map is created. The set method is used to add key value pairs to the map, where keys can be of any type, including strings, numbers, and booleans. The get method retrieves the value associated with a given key, and size property returns the number of key value pairs in the map. What is the DOM? The DOM, or Document Object Model, represents the document as a hierarchical tree of objects that can be modified with JavaScript. It allows us to change document structure, style, and content. Every part of a web page is represented as an object that can be accessed and manipulated by JavaScript. In the code, we're selecting an HTML element with the ID example using document.getElementById. Once selected, we're changing its text content to Hello DOM. By doing this, we're leveraging the DOM API to programmatically update the web page. Selecting and modifying elements. In JavaScript, the Document Object Model, DOM, allows you to select and modify HTML elements. Selection is usually the first step in DOM manipulation, which can be done using various methods like getElementById, getElementsByClassName, getElementsByTagName, or the newer querySelector and querySelectorAll. Once an element is selected, you can modify its properties, attributes, and content. This line of code first selects an HTML element with the ID demo using document.getElementById. It then changes the text inside the element to Hello World by setting the inner text property. This is a fundamental example of selecting an element by its ID and modifying its content in the DOM. Creating and removing DOM elements. In this section, we'll learn how to create new elements in the DOM and how to remove existing elements. This is fundamental to dynamic web page manipulation, allowing scripts to modify content and structure on the fly. The first part of the code snippet creates a new div element and a text node containing Hello World, appending the text node to the div, then appending the div to the document body. This adds the new div to the page. The second part of the code gets an existing div with the ID unwanted and removes it from the DOM by accessing its parent and using removeChild method. Event handling, add event listener, removing events. In JavaScript, events are used to respond to actions that take place in the browser. The addEventListener method allows you to set up a function to be called whenever the specified event is delivered to the target. To remove an event listener, you use the removeEventListener method. The code adds a click event listener to a button with the ID btn. When the button is clicked, the function handleClick is executed, logging button clicked to the console. The removeEventListener method is then used to remove the clickEventListener from the button, which means handleClick will no longer be called when the button is clicked. Event bubbling and capturing. In the context of the DOM, events propagate through elements to achieve event bubbling and capturing. Event bubbling means that an event starts at the most specific node and flows upwards to the least specific one, typically the document. Event capturing is the opposite. It starts from least specific node and goes down to the most specific one. In this code, 2 event listeners are added to the elements with IDs parent and child. The third parameter of the addEventListener function determines whether the event listening is in capturing, true, or bubbling, false or omitted phase. The listener on parent specifies true, indicating the capturing phase, so it runs when the event travels down the DOM. The listener on child does not specify the third parameter, so it defaults to bubbling and runs when the event travels back up the DOM after reaching the target element. DOM traversal. DOM traversal involves navigating through the document object model DOM, which is a tree-like representation of the web page's HTML structure. By traversing the DOM, you can access and manipulate elements, attributes, and text within the page. JavaScript provides methods to efficiently navigate the DOM tree, such as parents, children, and siblings. This code snippet demonstrates basic DOM traversal methods. It starts by selecting the first unordered list, LL, element on the page. Then it accesses the first and last child elements of the list, which are likely li elements if the list is properly structured. The next element sibling property is used to get the element immediately following the first list item, and previous element sibling fetches the element right before the last list item. These properties are handy for moving horizontally across elements at the same depth of the DOM tree. Changing element styles. In JavaScript, styles of DOM elements can be changed using the style property of the element. This property is an object that contains a CSS property as key and the style value as the corresponding value. In the provided code snippet, we select a DOM element using document getElementById with the ID myElement. Then we access the style property of this element. We set the color property to blue, which will change the text color of the element with ID myElement to blue. Form handling. Form handling in JavaScript involves interacting with form elements to collect and process user input. It's important to ensure that input data is validated, controlled, and potentially prepared for an HTTP request. In this example, we'll look at a simple contact form that collects a user's name and email. The code snippet begins by listening for the DOM content loaded event to ensure the DOM is fully loaded before attaching an event listener. It then attaches a submit event listener to the form with the ID contact form. When the form is submitted, we prevent the default form submission with e.preventDefault to handle the data with JavaScript. We collect the values of the form inputs with the ID's name and email and log them to the console. This example can be extended by including validation logic and AJAX requests to submit the form data to a server. Creating and handling dynamic content. Creating and handling dynamic content is a key aspect of web development. JavaScript provides methods to dynamically create, insert, and manage content in your web pages through DOM manipulation. This allows your applications to respond to user actions and change content without needing to reload the page. The code sample illustrates the process of creating dynamic content in the DOM using JavaScript. It starts by selecting an element with the ID content container. Then, it creates a new paragraph, p element, and sets its text content. Finally, the new paragraph is appended as a child to the selected container, thereby adding it to the page. Web APIs like Fetch API, Canvas API. The Fetch API provides a JavaScript interface for accessing and manipulating parts of the HTTP pipeline, such as requests and responses. It also provides a global fetch method that provides an easy, logical way to fetch resources asynchronously across the network. This code snippet makes a network request to the URL example.com/data using the Fetch API. It then processes the response as JSON, uses the resulting data as needed, in this case, logging it to the console, and catches any errors that may occur during the fetch operation. AJAX XML HTTP request fetch. AJAX is a technique for creating fast and dynamic web pages. It allows for updating parts of a web page without reloading the whole page. Here is how you can make a simple AJAX call using the XML HTTP request object. The code creates a new XML HTTP request object and configures it with the open method to make a GET request to a specified URL. The onReadyState event handler listens for changes in the object state. When the request is completed, ReadyState is done. It checks the status code to see if the request was successful or not. If successful, response text contains the response data. The send method is then called to send the request. Working with Files FileReader API, Drag and Drop API. The FileReader API allows web applications to read files stored on the user's computer, using file or blob objects to specify the file or data to read. In this code snippet, we start by selecting an input element of the type file. When a file is chosen, the change event is triggered and the handle files function is executed. Inside, we create a FileReader object, which is used to read the contents of the selected file asynchronously. When the reading operation is done, the onLoad event is triggered, and we log the contents of the file to the console. Local storage and session storage. Local storage provides a way to store data on the client's browser. The data has no expiration time and persists even after the browser is closed, unlike session storage. This code snippet first stores a value, associated with a key, in the local storage using localstorage.setItem. Then, it retrieves that value with localstorage.getItem, assigning it to the variable stored value. Cookies. Cookies are data stored in small text files on your computer. When a web server has sent a web page to a browser, the connection is shut down and the server forgets everything about the user. Cookies were invented to solve the problem by remembering stateful information for the user's browser session. Each time the same computer requests a page with a browser, it will send the cookie too. Here, the document.cookie is used to create a cookie named username with the value John Doe. A specific expiration date is set using expires, which specifies a date in UTC format when the cookie will be deleted. The path =/ means the cookie is accessible throughout the entire domain. If the path was /blog, the cookie would only be accessible from the path containing /blog. History API. The History API allows you to interact with the browser's session history, which is the list of pages the user has visited within your app on that particular tab or window. This includes navigating back and forward without a full page refresh, adding, modifying, and replacing entries in the history stack. This is crucial for creating a seamless user experience within single-page applications, SPAs. The code demonstrates how to use the History API to alter the browser's history stack. The pushState method adds a new state to history. It takes 3 parameters: the state object, the title, ignored by browsers but might be used in the future, and the URL. When the user clicks the back or forward button, the popState event is fired. The event handler set on window.onPopState gets called, and you can use event.state to access the state object for the active history entry. Navigator and screen objects. The Navigator object provides information about the user's browser, whereas the screen object holds information about the user's screen, such as its resolution. These objects are part of the window interface and are accessible via the global window object. This code snippet logs information regarding the user's browser and screen to the console. Navigator.appName gives the name of the browser. Navigator.appVersion provides the version details of the browser. Similarly, screen.width and screen.height give the width and height of the user's screen in pixels respectively. These properties are useful for understanding the environment in which the user is running your web application. Web workers. Web workers provide a way to perform work in a background thread, separate from the main execution thread of a web application. This allows for performance-intensive tasks to be handled without impacting the user interface. Since JavaScript in the browser is typically run in a single thread, web workers offer a means of achieving concurrency. This code checks if the browser supports web workers and then creates a new worker using the worker constructor, specifying the path to the script file worker.js. After creating the worker, the code sends a message to the worker using post message and sets up an onMessage event handler to receive messages from the worker. An onRow event handler is also set up to handle any errors that occur within the worker. Service workers and progressive web apps (PWA). Service workers act as a proxy between the web application and the network. They enable apps to control network requests, cache those requests to improve performance, and provide offline access to cached content. They are a core technology behind progressive web apps (PWAs), allowing for a more app-like user experience. This code checks if the browser supports service workers and then registers one via navigator.serviceworker.register when the window loads. The registration process involves pointing to a JavaScript file, service-worker.js, that contains the service worker code. Upon successful registration, a message with the registration scope is logged. If registration fails, an error is logged. Asynchronous versus synchronous execution. In JavaScript, synchronous code executes tasks one after the other, each task waiting for the previous one to complete before moving on. In contrast, asynchronous code allows tasks to be performed in the background, not blocking the main execution thread, which allows for a more responsive program, particularly when dealing with tasks like network requests, file operations, or timers. In the provided code, start is printed to the console first, followed by end, even though it is after the setTimeout function. This illustrates asynchronous execution. While the timeout is set for 2 seconds, JavaScript doesn't wait for it to complete before moving on to the next line of code. After 2 seconds, timeout will be printed to the console. This is possible because setTimeout is a non-blocking function that schedules code to be executed after a delay, allowing other code to run in the meantime. Event loop. In JavaScript, the event loop is a crucial component that enables asynchronous operations. It works with the call stack and the callback queue to manage the execution of tasks in a non-blocking manner. When the call stack is empty, the event loop transfers tasks from the callback queue to the call stack to be executed. In this code, first is logged immediately because it's a regular synchronous operation. The setTimeout function is then called with a delay of 0 milliseconds, but it doesn't execute immediately. Instead, the callback function provided to setTimeout is placed in the Web API environment, and, after the timeout, it moves to the callback queue. Meanwhile, the code continues to execute, and third is logged. Once the call stack is clear, the event loop moves the callback from the queue to the call stack, and second is finally logged. Callbacks. Callbacks are functions that are passed as arguments to other functions and are executed after some operation has been completed. They are a way to ensure certain code doesn't execute until after other code has finished its execution, which is particularly useful in asynchronous operations. In the code example, greeting is a function that takes name as a parameter and alerts a greeting message. The process user input function takes a callback function as its parameter. Inside process user input, we prompt the user for their name and then call the provided callback function, passing the user's name to it. In this case, when process user input is called with greeting as its argument, it will prompt the user for their name and then alert hello followed by their name after they input it. Promises creation chaining error handling. A promise in JavaScript is an object representing the eventual completion or failure of an asynchronous operation. It's a way of handling asynchronous code, offering a more flexible approach to asynchronous functions than traditional callback functions. In the code above, we create a new promise instance. The constructor receives a function with 2 arguments, resolve and reject. These are functions themselves that you call to either resolve or reject the promise. If the condition is true, we call resolve to indicate successful completion, passing the value we want the promise to be fulfilled with. If false, we call reject with a reason for the rejection. Async await. Async await is a syntactic feature in JavaScript that allows for cleaner and more readable asynchronous code. It is built on top of promises and allows us to write asynchronous code that looks and behaves a bit more like synchronous code, making it easier to understand and debug. In this code, fetchData is an asynchronous function marked by the async keyword. Inside this function, the await keyword is used before fetch to pause the function execution until the promise returned by fetch is resolved. Once the promise resolves, the execution continues with the response object. Then, response.json is also awaited on, suspending the function execution until the data is passed. If the promise rejects or any of these await statements throw an error, the catch block catches and handles the error. Timers set timeout, set interval request animation frame. Set timeout is used to execute a function once after a specified period of time has elapsed. The code sets a timer that will call the anonymous function after 2000 milliseconds, roughly 2 seconds. Once executed, hello after 2 seconds will be printed to the console. Try-catch statement. In JavaScript, the try-catch statement is used to handle exceptions and provide a way to respond to unexpected errors in a controlled manner. The try block contains the code that might throw an error, while catch is used to specify what to do if an error occurs. In the provided code snippet, potentially risky operation is a function that might throw an error. This function is executed inside a try block, which means JavaScript will attempt to execute the code normally. If everything goes well, it prints the result using console.log. However, if an error occurs, the catch block gets executed, and this is where we handle the error by logging it to the console with console.error. This approach ensures that the program doesn't crash, and we have an opportunity to handle errors gracefully. Throw statement. The throw statement in JavaScript is used to create custom errors. It allows you to generate an exception with a specified message or a specific error object. When you throw an error, the execution of the current function stops, and control is passed to the first catch block in the call stack. If no catch block exists, the program terminates. In this code, the function checkNumber is defined to take one parameter, num. Inside the function, we first check whether num is a numeric value using isNaN num. If it's not, we throw a simple string error, not a number. If it is a number but greater than 99, we throw a new error object with the message, the number is too large. If num is a number and less than 100, it returns the number. In the try block, we attempt to call checkNumber with 150, which is greater than 99, thus the throw statement generates an error, and execution is moved to the catch block where the error is logged to the console. Custom error types. In JavaScript, errors can be categorized into built-in error types such as syntax error, reference error, type error, etc. However, there might be situations where custom logic is needed for errors specific to a particular application. In such cases, one can define custom error types by extending the built-in error object. This process involves creating a new class that inherits from the error class and possibly adding additional properties or methods that are suited for the application's needs. In the provided code, we define a validation error class that extends the built-in error class. The constructor calls superMessage to ensure that the error part of the instance is properly initialized with the message provided. We also set a custom name, validation error, for the error, and a default HTTP status code that could be used when sending responses in a web application context. The validate user function is an example where the custom error might be thrown. When calling validate user, we use a try-catch statement to catch the error. The catch block checks if the error is an instance of validation error to handle it accordingly, differentiating it from other potential errors. Error event handling. In JavaScript, the error event is emitted when an error occurs within an asynchronous event, such as a problematic script loading or a runtime error that isn't caught by a try-catch block. Error event handlers allow us to gracefully handle such errors. The provided code listens for the error event on the window object, which is the global scope in a browser environment. When an error occurs, the event handler function is called. Inside this function, event.message contains a descriptive error message. By logging this message, it helps developers to understand what went wrong. Returning false from the event handler prevents the browser's default error handling mechanism, such as logging to the console or showing an error dialog, allowing for a more controlled and customized error reporting behavior. Debugging techniques using developer tools. Developer tools in browsers like Chrome or Firefox are powerful environments for diagnosing and fixing issues in JavaScript code. One can utilize various debugging techniques, such as breakpoints, watch expressions, and console logs to track down and resolve problems. In the given code snippet, the debugger statement is used to insert a breakpoint. When this code runs in the browser with developer tools open, the execution will pause at the breakpoint. Then you can examine variables, step through code, and evaluate expressions to understand the bug's cause. In this example, passing a string instead of a number as the second argument will lead to an incorrect sum, which can easily be diagnosed once the code execution is paused. Understanding ES6 modules. ES6 modules use export to expose functions, objects, or primitive values from a module so they can be used by other programs with the import statement. In this example, math.js exports two functions, add and subtract. The main.js imports these functions and uses them. Notice the use of relative path math.js to refer to the location of the module. Importing and exporting modules. In JavaScript, modules allow you to break up your code into separate files. Each file encapsulates the related code. This structure makes it easier to maintain and reuse code. To share code between modules, you use export to make it available and import to get access to it. In this example, we have two files, math.js and app.js. In math.js, we define a function named add that adds two numbers, and we use export to make this function available for other modules to use. In app.js, we use import to access the add function from math.js by specifying the function's name in curly braces and providing the relative path to the module. Finally, we call the add function and print the result. Default and named exports. In JavaScript ES6, modules allow you to break up code into separate files, which can enhance maintainability and reusability. A module can export entities such as functions, objects, or primitives. There are two types of exports: default and named. Default exports allow you to export a single entity per module, while named exports let you export multiple entities. Each named export can be imported with the exact name used in the export statement. In mathfunctions.js, two functions add and subtract are exported as named exports. These can be imported by enclosing their names in curly braces. In utils.js, the greet function is exported as a default export, meaning when it's imported, we don't use curly braces and can choose any name for it, like greet user, in main.js. It's important to remember that a particular module can have only one default export, but numerous named exports. Dynamic imports. JavaScript modules can be imported dynamically within a module or a script using the dynamic imports syntax. This is an ECMAScript proposal that enables you to load modules on demand. It returns a promise that resolves into a module object that contains all the exports of the loaded module. In the given code, if condition is true, then /module.js is imported dynamically using the import function. The function call returns a promise, which, upon successful resolution, gives us access to the module and all the exported members. This code then utilizes the then method to interact with the module, or the catch method to handle errors. This approach enables conditionally loading modules and can be useful for performance optimizations, such as code splitting in web applications. Module patterns. IIFE revealing module pattern. The IIFE immediately invoked function expression revealing module pattern is a JavaScript design pattern that allows for the creation of modules by self-executing a function to create a closed scope. It reveals selected methods and properties to the outside scope while keeping others private. In the code, an IIFE executes immediately to create a private scope. The private var and private function are not accessible outside this function. Public var and public function are exposed via an object assigned to window.myModule, allowing them to be called from outside the function scope. The revealing module pattern makes it clear which properties and methods are public by returning an object with references to the public functionality. This pattern helps maintain organization and protects the module's state from unintended interference. Template literals. Template literals are string literals allowing embedded expressions which can be multi-line and enable string interpolation. They're enclosed by backticks instead of single or double quotes. In this code, user, and amount are variables that hold the values Alice and 5 respectively. Using template literals, we construct a string message that incorporates these variables directly within a string literal. Syntax is used to embed expressions, in this case variable names, into the string. Tagged template literals. Tagged template literals are an advanced form of template literals. A tagged template is a function call that uses a template literal from which to get its arguments. The tag is simply a function placed in front of the template literal. This approach allows us to parse template literals with a function, which can then manipulate the output, escaping strings, internationalizing them, or constructing higher-order data structures from them. In the provided code, highlight is a tag function that takes a template literal and its values. The strings parameter receives an array of string segments, while values gathers all the interpolated expressions. The .reduce method is used to combine these parts into a single string, surrounding each interpolated expression with mark tags for emphasis. When called with highlight tactic hello actic, the function outputs hello mark world mark, with world emphasized within mark tags. This example illustrates how tagged template literals can be used to customize the processing of template strings. Object literal enhancements. Object literal enhancements in JavaScript are a set of syntax improvements that make it easier and more intuitive to handle objects. These enhancements allow developers to write more concise code when dealing with object properties and methods. In the code snippet, name and age are external variables that are used as property values within the person object, without having to repeat name, and age. This shorthand property notation simplifies the object definition. Additionally, the greet function is defined without the need for the function keyword, making it more succinct. When person.greet is called, it returns a greeting string that includes the name property from the same object. Arrow functions and lexical this. Arrow functions introduced in ES6 offer a more concise syntax and lexically bind the this value. This means that this inside an arrow function is the same as this outside the function. In the provided code, the team summary function is a traditional function that has its own this context, referencing the team object. The map method is called on the team.members array with an arrow function passed as its argument. The arrow function uses this to reference the team name property of the team object. Because arrow functions do not have their own this, they inherit it from the surrounding context, team summary function in this case, enabling the use of this.teamName within the arrow function without any issues. Enhanced object destructuring. Object destructuring is a convenient way to extract multiple properties from an object into individual variables. In modern JavaScript, destructuring has been enhanced with new capabilities such as providing default values, renaming variables, and nested destructuring. It makes the code more readable and concise, especially when dealing with complex objects. The code above demonstrates multiple aspects of enhanced object destructuring. A user object is created with 3 properties: name, age, and a nested contact object. In the destructuring expression, name is being renamed to username, allowing us to refer to it with a different variable name. The age is destructured with a default value of 30. This default is unused since user.age exists. Lastly, the email is pulled out of the nested contact object. The console logs Alice, 25, and Alice at example.com, reflecting the value transformation and nested destructuring. REST spread properties. REST and spread properties are 2 features introduced in ES6 that allow for more succinct and flexible handling of object and array elements. The spread syntax can be used to expand elements from an array or properties from an object. Conversely, the REST parameter is used to collect a series of elements into an array or properties into an object, often when destructuring. In the code provided, the REST parameter is used to collect the remaining properties of the user object after destructuring the name. The variable name gets the value John Doe, while REST gets the remaining properties as an object, age and email. Similarly, with the array numbers, the first element is assigned to first, and the rest of the elements are put into an array called REST numbers. Async iteration and generators. Async iteration and generators are features in JavaScript that allow you to work with sequences of data that are generated asynchronously. This is useful when dealing with streams of data that may be arriving over time, such as results from a web API. An async iterator is an object that implements a next method that returns a promise for an object with properties value and done. An async generator function is a special type of function that can pause and resume its execution while maintaining its context, and it produces an async iterator. The code defines an asynchronous generator function, async generator, that yields numbers from 0 to 2 with a delay between each yield. It simulates an asynchronous operation using setTimeout. Each yield in an async generator function returns a promise of the next value when awaited. The forAwait dot of statement is used to iterate over these returned values from the async generator. During each iteration of the loop, the code waits for the promise from the yield to resolve before logging the value and continuing with the next iteration. Symbols. In JavaScript, a symbol is a primitive data type, just like number, string, or Boolean. It represents a unique token that can be used as an identifier for object properties. Each time you create a symbol, it is entirely unique, even if you give it the same description as another symbol. In the provided code, we create two symbols, both with the description mySymbol. Despite having the same description, they are unique. When we compare sim1 and sim2 for equality using ==6, it returns false because every symbol is completely unique from every other symbol. Symbols are often used to add unique property keys to objects that do not conflict with any other properties and are not enumerable in for and in loops. Proxies and Reflect API. Proxies in JavaScript offer a powerful way to customize behavior of objects at a low level. They allow you to define custom behaviors for fundamental operations, e.g., property lookup, assignment, enumeration, function invocation, etc. The Reflect API provides methods for interceptable JavaScript operations, aligning closely with the operations that proxies can hook into, thus offering a way to perform default operations on objects. In this code, we create an empty object target and a handler object that defines a get trap. This trap intercepts attempts to access properties on the target. If the property exists on the target, it returns its value, otherwise it returns the number 42. We then create a proxy for the target using the handler. When we attempt to access proxy.a, since a is not a property on target, the get trap activates and returns 42 as specified in the handler. Code style and linting. Adopting a consistent code style and using a linter can help maintain the quality of the code by enforcing consistency and identifying potential errors. The code provided is an example ESLint configuration file. ESLint is a popular static code analysis tool for identifying problematic patterns in JavaScript. This configuration sets the environment to Browser and ECMAScript 2021, extends the recommended ESLint rules, and specifies parser options for ECMAScript modules. The rules define code style preferences, such as indentation, 2 spaces, line break style, Unix, quotes, single, and mandatory semicolons. Developers incorporate such tools into their development workflow to ensure compliance with coding standards and to prevent potential errors before they happen. Avoiding globals. In JavaScript, global variables can create conflicts and difficult to maintain code due to potential clashes in the global namespace. Therefore, it's a best practice to minimize the use of global variables by encapsulating them within functions or using the module pattern. Let's see how we can avoid globals by using a function to encapsulate variables. In the provided code, local var is a variable that is defined within the function myFunction. It is not accessible outside of this function, which ensures that it does not pollute the global space. When we attempt to log local var outside the function, the console will output undefined, demonstrating that the variable is local and hence does not exist in the global scope. This is beneficial for avoiding name conflicts and reducing the risk of accidental modifications to global values. Using strict mode. Strict mode is a feature introduced in ECMAScript 5 that allows you to opt in to a restricted variant of JavaScript. When strict mode is enabled, certain actions that would otherwise be ignored or would fail silently will now produce errors or throw exceptions. This vigilant behavior helps you catch common coding bloopers, prevents the use of some potentially problematic syntax, and makes it easier to write secure JavaScript. The code begins with the useStrict directive, which can be placed at the beginning of a script or inside a function to apply strict mode to the entire script or the function, respectively. In the provided code, a function named can only use strict is declared with its own useStrict directive, thus applying strict mode to the function's scope. Within the function, a variable undetected mistake is intentionally misspelled in the next line as undetected mistake, which would silently fail without strict mode. However, with strict mode enabled, this typo causes a reference error to be thrown, alerting the developer to the mistake. Writing readable code. Readable code is essential for team collaboration and maintenance. It makes understanding, sharing, and altering code by someone other than the original author much easier. Let's focus on how to enhance readability through clear naming, concise functions, and proper commenting. The calculate area function is a good example of readable code. It uses descriptive names for the function and its parameters, width and height, making it clear that it calculates the area of a rectangle. Comparatively, CAWH is less clear because CA could stand for anything, and W and H don't immediately suggest width and height. Descriptive naming is a cornerstone of readable code, as it communicates intent and reduces the need for additional comments. Refactoring and code smells. Code smells are indicators of potential issues in your code that may require refactoring. They aren't bugs, rather, they can hinder maintainability and extensibility. The provided code has several code smells: magic number for the tax rate, iteration using a for loop that could be simplified, and calculating the subtotal within the same function that applies tax, which could be separated for clearer logic. Refactoring would aim to remedy these issues. Code documentation. Good documentation is critical for JavaScript development. It enhances code clarity, maintainability, and eases the onboarding of new developers. Comments, JSDoc, README files, and inline documentation are some of the ways to document your code. The provided code snippet uses JSDoc comments to document a simple function called add. It describes the purpose of the function, its parameters with their types, and the return type. This information aids developers in understanding the function's usage and intent, without diving into the implementation details. Performance optimization. Performance optimization in JavaScript involves improving the speed and efficiency of your code. There are various techniques and best practices that can minimize the time it takes for your code to execute, reduce memory usage, and enhance the overall user experience. One common area for optimization is loop performance, especially when dealing with large datasets or complex algorithms. In the provided code, we're caching the array length in a local variable len, instead of accessing the length property of the array on each iteration. This can significantly improve loop performance because the length calculation is done only once instead of being recalculated on each iteration of the loop, which can be costly if the array is large. Optimizing loops in this manner is a simple yet effective way to enhance JavaScript performance. Memory management. In JavaScript, memory management is predominantly handled by a garbage collector, which automatically deallocates memory that is no longer in use by the program. This means that developers generally don't need to manually release memory, but they must still be aware of how their code can interact with the garbage collector to avoid memory leaks. In this code snippet, we create two objects, Object A and Object B, and create a circular reference between them. When we set both variables to null, there are no remaining references to these objects from the reachable code. Hence, the garbage collector can reclaim the memory. Without setting them to null, the circular reference would have prevented garbage collection, possibly leading to a memory leak. This demonstrates the significance of breaking down circular references to allow the garbage collector to work efficiently. Introduction to testing. Testing in JavaScript refers to the process of writing automated tests to ensure that your code functions correctly. It's an essential aspect of software development that helps developers catch bugs early, simplify integration, and allow for safe refactoring. Types of testing: unit, integration, functional. Unit testing involves testing individual components or functions of a software application in isolation. It's typically done to ensure that each unit of the software performs as designed. A unit can be a function, method, or class. JavaScript unit testing can be done using various frameworks like Jest, Mocha, or Jasmine. In the provided code snippet, we define a simple unit add function that takes two arguments and returns their sum. The Jest testing framework is used to describe a test suite for this unit. Inside the suite, we have a single test that checks if the add function correctly adds two numbers. The expect method is used to assert the result of calling add with arguments 1 and 2, which should be 3. Testing frameworks: Jest, Mocha, Jasmine. Jest is a delightful JavaScript testing framework with a focus on simplicity. It works out of the box for any React project, but can also be used with other JavaScript frameworks. Jest is used by Facebook to test all JavaScript code, including React applications. The code defines a simple test using Jest to check if the sum function correctly adds two numbers. The test function is used to define a test case, with a descriptive string and a callback function containing the test logic. The expect function is used to assert the expected result, with to be checking for strict equality. Assertion libraries. Assertion libraries are tools that allow developers to write tests which validate whether a particular piece of code behaves as expected. They provide a set of assertion functions that check conditions and throw errors when the conditions are not met. This helps in creating automated tests that clearly state the expectations and verify the correctness of the code. In the provided code snippet, we are using the chai assertion library, which is a popular choice among JavaScript developers. We require chai and access its assert interface. We then declare a variable value to be 2. Using the assert.isBelow function, we are checking if value is less than 100. If value is not less than 100, the assertion will fail, and an error will be thrown with the message value should be below 100. Test runners. In the context of software testing, a test runner is a program that runs tests written for a piece of software to determine if it passes or fails specified conditions. Test runners can provide useful feedback on the test processes, like which tests passed, which failed, and why. They can also help automate the testing process. Some popular JavaScript test runners include Jest, Mocha, and Jasmine. In the code snippet provided, Jest is being installed as the test runner using npm. A test file sum.test.js is created containing a test case that imports a sum function from sum.js not shown and expects that calling sum12 will return 3. The test function defines the test with a description and a callback function containing the actual test code. Expect is the assertion, checking the result of the sum function. The last command, npm test, is used to run Jest and execute the test case in sum.test.js. Mocking and spies. In JavaScript testing, mocking and spies are techniques used to simulate the behavior of complex pieces of code or to observe the interactions between the tested code and its dependencies. Mocking allows you to create stand-in objects or functions with predetermined behavior to isolate the unit of code you're testing. Spies, on the other hand, wrap existing functions, allowing you to record information about how they were called. In the code above, we first mock a module's method using Jest's jest.mock function, providing a fake implementation that returns a mocked value. This ensures that whenever some method is called within the tests, it will not perform its real function, but instead return the mocked value, thus not affecting external systems or relying on their state during the test. Next, we create a spy on someObject.some method using jest.spyon. After the method is called with an argument, we use expect to assert that the spy was called with the correct argument. This is useful for verifying that the tested code interacts correctly with the spied-on method. Code coverage. Code coverage is a metric used to gauge the extent to which your source code is executed during testing. It helps identify untested parts of code, ensuring that all features are validated and that the risks of bugs slipping through are minimized. Achieving high code coverage can lead to more robust, reliable software. In the code snippet, we define a simple add function that adds two numbers and a test case for this function. Code coverage tools would run this test and report the percentage of the code exercised by it. In this case, if this were the only function in our codebase and the test runs successfully, code coverage would be 100% for this function. However, if there were more functions or branches, like if-else conditions, within the function that were not called by our tests, code coverage would be lower. End-to-end testing with Puppeteer and Cypress. Puppeteer is a node library created by the Google Chrome team, which provides a high-level API to control Chrome or Chromium over the DevTools protocol. It's typically used for end-to-end testing, scraping web applications, and generating pre-rendered content from SPAs. We will use Puppeteer to write a test that visits a page, interacts with elements, and verifies correct functionality. In the given code, Puppeteer is imported and used to programmatically launch a browser instance. An asynchronous function is declared to avoid callback nesting. A new page is opened in the browser, and the script navigates to h/example.com. It then retrieves the page title and asserts that it matches the expected title, example domain. If the assertion fails, an error will be thrown. Finally, the browser is closed. This script represents a basic end-to-end test checking that a page's title is as expected. Functional programming concepts. Functional programming is a programming paradigm that treats computation as the evaluation of mathematical functions and avoids changing state and mutable data. In JavaScript, this means leveraging functions as first-class citizens, using pure functions and higher-order functions like map, reduce, and filter for operations on collections of data. In the provided code snippet, numbers is an array of integers. The map function is used to iterate over each item in the array, applying a function to each item. The function provided to map takes each number and returns it doubled. The result is a new array, doubled, containing the doubled values. This demonstrates a key concept in functional programming: the use of pure functions, functions that do not alter the original data and have no side effects, to transform data without mutating the original array. Currying and partial application. Currying is a transformation of functions that translates a function from callable as fabc into callable as fabc. Partial application is a technique for fixing a number of arguments to a function, producing another function of smaller arity. In this example, the curry function transforms the sum function into a curried version. The curried sum function can be called with one argument and returns a new function waiting for the second argument. This is useful for scenarios where a function's arguments might be received at different times. Pure functions. In functional programming, pure functions are a core concept. A pure function is a function that satisfies two conditions. It always returns the same output given the same input, and it has no side effects. This means that a pure function doesn't rely on or modify the state outside its scope. No external variables, no I/O operations, etc. Pure functions offer predictability and are easier to test and debug. The add function takes two arguments, a and b, and returns their sum. This function is pure because it always produces the same output for the same set of inputs and does not cause any side effects. It doesn't modify any external variables, nor does it depend on any state other than the input arguments. Therefore, it is deterministic and considered a pure function. Immutable data patterns. Immutable data patterns involved strategies for managing data in a way that prevents its original state from being changed. In JavaScript, common approaches to enforce immutability include the use of const declarations, immutable.js library, or newer language structures such as object and array spread. Immutability is a powerful concept in programming, especially in functional programming and state management within complex applications. It avoids unintended side effects and makes the application state more predictable and easier to understand. In the code snippet, we first declare an object, obj, which represents a person with a name and age, and we use object.freeze to prevent modifications to this object. Next, when we want to create a new object with an updated age, we use the spread operator to copy the original object's properties, and we overwrite the age property. Since we have not altered the original obj, but instead created a new obj, we have adhered to an immutable data pattern. Reactive programming with RxJS. Reactive programming is a programming paradigm oriented around data flows and the propagation of change. RxJS, Reactive Extensions for JavaScript, is a library for reactive programming using observables that makes it easier to compose asynchronous or callback-based code. It provides a core type, the observable, and satellite types like observer, schedulers, subjects, etc. This code snippet creates an observable that, when subscribed to, emits a sequence of numbers 1, 2, 3, and after a second, emits another value 4 and completes. An observable is a producer of multiple values, pushing them to subscribers. The subscribe method is used to start the observable execution and provide the handlers for received values, errors, or the completion of the stream. The console.log statements outside of the subscription demonstrate that observables are asynchronous by nature, as just after subscribe will log before the values are received. State Management Redux. Redux is an open-source JavaScript library used for managing application state. It is most commonly used with libraries such as React or Angular for building user interfaces. Redux is based on the Flux design pattern and helps you manage the state of your app in a single store, which simplifies the control of state, especially in large applications. The code demonstrates the basic usage of Redux for state management. We begin by importing the createStore function from Redux. Then we define a reducer function counter, which updates the state based on the action received. The createStore function takes the reducer as an argument to create a new Redux store. The store.subscribe method allows us to listen to state updates, and store.dispatch is used to send actions to the store in order to update the state. Here, we dispatch increment and decrement actions to change the state value. Advanced Asynchronous Patterns Observable Streams. Observables provide a way to handle asynchronous streams of data. They are part of the reactive programming paradigm and are implemented in JavaScript through libraries like RxJS, Reactive Extensions for JavaScript. Observables are similar to promises, but can emit multiple values over time. Once an observable is created, observers can subscribe to it and react to the data as it arrives. Let's look at a simple example using RxJS to create an observable stream of numbers that are emitted every second. An observable is created using new observable, subscriber equals bool, where subscriber is an object that has next, error, and complete methods. setInterval is used to emit a count value every 1,000 milliseconds, 1 second. Subscriber.next counts plus sends a value to any observer that is subscribed. The count is increased until it is greater than 5, at which point clearInterval stops the interval from continuing, and subscriber.complete ends the observable sequence. Next, we subscribe to the observable using observable.subscribe, providing an object with handlers for the next, emitted values, error in case of an error, and complete when the observable completes events. WebSockets and real-time communication. WebSockets provide a way to establish a persistent, low-latency full-duplex communication channel between a client and a server over the web. This is essential for applications requiring real-time interactions such as chat applications, live feeds, and interactive games. This JavaScript snippet opens a WebSocket connection to ws/example.com/socket server. The onOpen event listener sends a message to the server when the connection opens. The onMessage listener logs received messages. onClose handles when the WebSocket closes, and onRA captures and logs any errors. WebAssembly integration. WebAssembly, WASM, is a binary instruction format that provides a way to run code written in multiple languages on the web at near-native speed. When integrated with JavaScript, it enables high-performance applications on the web. The following example shows how to load a WebAssembly module using JavaScript. The code shows the use of WebAssembly.instantiate streaming to fetch and instantiate a .wasm module. Fetch is used to retrieve the module, and import object can provide imports to the module, like JavaScript functions or WebAssembly.memory. After the promise resolves, the results object contains an instance with exports that can be called from JavaScript. Exported func is an example of such an exported WebAssembly function. Version control with Git. Git is a distributed version control system that helps track changes in source code during software development. It's designed for coordinating work among programmers, but it can be used to track changes in any set of files. It provides features for branching, merging, and rewinding projects to previous states. The code snippet is the command to initialize a new Git repository. When you run git init, Git creates a new subdirectory named .git that contains all of your necessary repository files. This directory is where Git stores the metadata and object database for your project. This makes the current directory a Git repository, which can now track changes. Bundler's Webpack Parcel. In modern web development, bundlers are tools that compile code and resources, such as JavaScript, HTML, and CSS, into a package that's optimized for browsers. Webpack and Parcel are popular bundlers that simplify the processes of dependencies management, code transformation, and optimization. The provided Webpack code is a basic configuration file for a JavaScript project where entry is the entry point file, and output specifies the file name and directory for the generated bundle. The module section defines loaders that transform the code, such as using Babel to transpile modern JavaScript into a format that can be understood by most browsers. For Parcel, much of this configuration is handled automatically. You only need to run the command with an entry file, like an HTML file that references your JavaScript, to get started with zero configuration. Task runners, NPM scripts gulp. NPM scripts are a convenient way to automate repetitive tasks by placing them in the scripts section of the package.json file. They can be used to run custom shell commands or other NPM packages directly. The provided code snippet shows a scripts section from a package.json file. npm start will execute node-index.js, running the main application file. npm test will run the testing suite using Jest. npm run build will execute Webpack with the specified configuration file to build the application. Transpiling Babel. Babel is a popular JavaScript transpiler that allows developers to use next-generation JavaScript by converting ES6 and beyond code into a backward-compatible version that can run in current and older browsers or environments. The code demonstrates a simple arrow function definition in ES6 syntax, which Babel transpiles to an ES5-compatible function expression. This ensures the code can run in environments that don't support ES6 features, such as arrow functions. Code minification and uglification. Code minification is the process of removing all unnecessary characters from source code without changing its functionality. These include whitespace, new lines, comments, and block delimiters, which are used to make the code more readable for humans but are unnecessary for machines. Uglification is a step further, where the code is transformed into an unreadable form by renaming variables to shorter names to reduce size and potentially obfuscate the code to make it harder to understand. The original function named sum, taking two parameters a and b, is written with proper whitespace and formatting for readability. The minified version removes the extraneous spaces and the comment. The uglified version renames the function to s to shorten the overall code length, saving bytes and potentially making the code less comprehensible if someone were to look at the source. Source maps. Source maps are files that provide a way to map code within a compressed file back to its original source. They enable you to see the original source code when debugging minified JavaScript or CSS, instead of the compressed code. When JavaScript is minified, all whitespace is removed, and the variables are often renamed to shorter names. This process makes the code difficult to read and debug. A source map is a file that maps from the transformed source to the original source, thereby allowing the browser to reconstruct the original source and present it in the developer tools. The source mapping URL comment at the end of the file provides the browser with the location of the source map. Development servers, Live Server Express. Development servers are tools that allow developers to test their websites or web applications locally before deploying them to the public. Live Server is a simple, zero-configuration development server commonly used for static pages, while Express is a minimal and flexible Node.js web application framework used to build powerful web servers and APIs. The provided code is a basic setup of an Express server in Node.js. It starts by importing the Express module, then creates an instance of Express by calling Express. The GET method is set up to respond to HTTP GET requests at the root URL with the text "Hello World." The server is then started on port 3000 with listen, and a message is logged to the console to indicate that the server is running. Containerization Docker. Docker is a platform for developers to develop, deploy, and run applications with containers. Containers are lightweight, standalone packages that contain everything needed to run a piece of software, including the code, runtime, system tools, libraries, and settings. This Docker file begins with a Node.js image as the base from Node 14. It sets the working directory inside the container to /app, workdir app. The current directory's contents are copied into the container, scopy. It then runs npm install to install the application's dependencies, run npm install. The container is told to expose port 3000 to the outside world, expose 3000. Finally, it defines the command to run the application, xment node app.js. Introduction to frameworks and libraries. In JavaScript ecosystem, frameworks and libraries are essential tools that provide reusable code to handle common tasks. They help developers to write applications quickly and efficiently. Libraries offer a collection of functions and methods that a developer can call to perform specific tasks, whereas frameworks provide a more structured environment and define the architecture of your application, often enforcing certain patterns and practices. Since this is an introduction, there's no code to demonstrate. The key takeaway is that libraries provide specific features that you can incorporate into your code as needed, while frameworks often dictate the overall structure of your application. Examples of libraries include jQuery, Lodash, and D3.js, which help with DOM manipulation, utility functions, and data visualization respectively. Frameworks like Angular, React, and Vue.js provide scaffolding for building client-side applications. The choice between using a framework or library depends on the project's requirements and the level of flexibility or structure you need. Choosing the right framework or library. When embarking on a new project or trying to integrate new features into an existing one, it's important to choose the right framework or library that matches your project's needs. Factors such as the size of the project, the expertise of your team, performance requirements, community support, and long-term maintenance should be considered. Since this is more of a conceptual topic, there isn't a specific code example to provide. However, imagine you assess various frameworks like React for building user interfaces with a strong component-based approach, Angular for a comprehensive solution, including features like two-way data binding and services, or Vue, which is often appreciated for its simplicity and incrementally adoptable ecosystem. You'd weigh the pros and cons like React's rich ecosystem and community support versus Angular's steep learning curve or Vue's ease of integration into projects. Basic concepts of React. React is a JavaScript library for building user interfaces. It enables developers to create large web applications that can change data without reloading the page. It's component-based, which means we build encapsulated components that manage their own state and compose them to make complex UIs. In the provided React code, we first import the React library. Then, we define a functional component named hello component using the function syntax. Inside it, we return JSX, a syntax extension to JavaScript that describes the UI, in this case, an h1 tag with hello world. Finally, we export the hello component to be used in other parts of our application. Basic concepts of Angular. Angular is a popular JavaScript framework for building web applications. It is maintained by Google and a community of developers. Angular utilizes TypeScript, which is a superset of JavaScript, to help catch errors early during development. Here, we will explore some of its core concepts, like components, modules, services, and data binding through a simple example. In this code snippet, we define a new Angular component using the @component decorator, which allows us to specify metadata for the component. The selector app_hello_world defines the custom HTML element used to place our component in a template. The template property contains the HTML that will be rendered, including the data-bound property name, which is interpolated within the h1 tag using double curly braces. The Hello World component class then defines the name property, which is bound to Angular, resulting in the rendering of Hello Angular on the page. Basic concepts of Vue.js. Vue.js is a progressive JavaScript framework used for building UIs and single-page applications. Key concepts include reactive and composable data bindings. Here, we'll create a simple Vue app with a message that users can change. The HTML code sets up a div with an ID of app, where our Vue instance will be mounted. Message is a placeholder that displays the message property from the Vue instance data. In the script, we load Vue from a CDN and then create a new Vue app using createApp. Data is a function that returns an object containing our model data, in this case, a message. The message starts as Hello Vue. When the app instance is mounted to the div with the ID app, Vue's reactivity system binds the message from the data to the template, which means any changes to message will automatically update the DOM. Handling state in UI libraries frameworks. In React, state management is typically handled within components using the state hook, useState, for functional components. A component's state is its private data that can change over time. When the state changes, the component responds by re-rendering. In the code above, useState is used to create count state variable, initialized with 0. The setCount function updates this state. When the button is clicked, it calls setCount with the new state value, currentCount plus 1, which triggers a re-render of the counter component, showing the updated count. Component-based architecture. Component-based architecture is a design approach that structures an application as a collection of reusable and independent components. Each component encapsulates its functionality and can be easily integrated with other components to create a complex application. This architecture is widely used in modern JavaScript frameworks such as React, Vue, and Angular. In the code, we define a button component using React's class-based component system. This button component can be reused wherever a button is needed in the application. It receives props, which are parameters passed into the component, and in this case, it's the button label. Then we define an app component which utilizes the button component and sets its label to click me. The button component encapsulates all the HTML markup and behavior for a button, allowing for a modular and maintainable codebase. Server-side rendering SSR versus client-side rendering CSR. In web development, rendering refers to the process of generating the HTML content that will be sent to the client's browser. Server-side rendering, SSR, generates the full HTML for a page on the server before sending it to the client. Client-side rendering, CSR, on the other hand, sends a minimal HTML structure with JavaScript to the client, where the rendering takes place, creating elements and content dynamically. SSR is usually implemented in frameworks like Next.js for React or Nuxt.js for Vue. It offers better SEO and faster initial load times. CSR, employed by client-side frameworks like Create React App or Vue CLI, offers rich user interactions and eases development by separating the client and the server. SSR can also be more challenging to implement due to the need for a Node.js server environment, whereas CSR can run on any static file server. Static site generators, Gatsby, Next.js, Nuxt.js. Static site generators are tools that compile and generate a set of HTML, CSS, JavaScript files from templates and content, often written in Markdown or other template languages. They are used for building fast and scalable websites because the content does not change dynamically with each request. Gatsby, Next.js, and Nuxt.js are all popular SSGs, each with unique features and based on popular front-end frameworks like React and Vue.js. Here's a brief intro to each one. Each SSG has its own set of conventions for how sites are built. Gatsby is based on React and optimizes the site for speed by leveraging GraphQL and a rich ecosystem of plugins. Next.js, also based on React, is highly versatile and can be used for both static site generation and server-side rendering. Nuxt.js is based on Vue.js and provides a similar set of functionalities as Next.js, but within the Vue.js ecosystem. These tools help developers optimize for performance and productivity.